Welcome back to the Tin Barn. I'm Pragmatic Lee, and today's video is going to deal with using an indicator in a lathe. Most of you are familiar with using a Noga stand or a Noga style stand with a magnetic base, attaching it to the front of the lathe, facing that up to bump against your work, centering in a 4-jaw chuck, or maybe even centering your collet chuck. The problem with these type indicators on the smaller lathes, such as mine, 11-inch lathe, is that there's just not a lot of room on the front of the lathe for the magnet to connect to. So I went to looking into various styles of mounts for the quick change tool post. I think most of you have seen where someone would take a piece of material, mount an indicator to the side of it, such as this, and clamp that in to one of the quick change tool holders. Perfectly viable solution, but it's got a limitation of two limitations that I could see on there. One, it uses up one of your tool holders, and secondly is what this video and this tool I hope will alleviate. It's only good for facing into centering. It doesn't help you enter any if you wanted to go in longitudinal, if you want to go in to the end of a workpiece to be sure you've got it straight in the chuck. Now, to alleviate the problem, or not the problem, but the issue of using one of your tool post holders, you can always machine in the dovetail in a piece of stock, this is one I did before, and just using the hole in the indicator base, you can mount that right down on your quick change tool post, and go ahead and set that height so that it's in the center of your material. That works well, again, if you're wanting to butt up to the piece. But if you wanted to turn this to be sure the piece is straight in the chuck, this is pointing in the wrong direction. If you turn it over, which would still slide over the dovetail, now you can't see the dial. So you'd have to take it off, flip it over, put the bolt back in, and your height adjustment would be in the way then. So what we're going to look at today is a solution that I saw quite by accident. I was watching one of Thomas Knack's videos where he was making some tops, spin tops for his children for Christmas, or for Christmas presents. I'm not sure if they were his children. But caught just a quick 3-4 second glimpse of the indicator holder that he was using. He's got a video on making the indicator holder. I'll try to put that up here as well. But in that video where he makes it, he puts a height adjustment tool, height adjustment on it as well. And what I saw in the video where he was making the tops for the children, this one right here, yeah, be sure I'm pointing in the right direction. It didn't have the height adjustment on it, which you don't need. You don't have it on this anyhow. You're gonna feel for it and lock it into place wherever you find the high spot. But I'm going to show you a quick little clip. It's only about a 3 or 4 second clip out of Thomas's video. I hope it's okay with him. Again, I've linked, provided a card link to it. But I was intrigued with what he did in that little clip, and rewound it and played it back and forth several times until I finally got an idea, got it in my head what he was doing there. So I'm going to get the camera turned around here. I've made a little drawing of what we're going to build, and I'm going to get the camera turned around where that you can see it, see the drawing, and then we'll start working on it. What we'll be starting with is a piece of 3" by 3" by 1" thick aluminum stock. I happen to have some 1" thick stock. 3/4 would be perfectly fine for this, but like I say, I've got some 1". We're going to take out a pretty good section here, leave 1" over here, and 1/2" on the top edge. Now the dovetail itself, just put a note here, dovetail to match specifications of the quick change tool post that you're using. I'm using an AXA, and over here on the side, I've replicated the part of this drawing that is applicable to the dovetail, and I will take some measurements in a minute off of one of the quick change tool holders. But it will have a 3/8 inch hole drilled through right here. That is where the indicator will go through and mount. Over here there will be an 832 socket head cap screw counterbored into the top edge, and this will be slit. There will be a slit cut in that to give a clamping action. What we'll do, once we get the dovetail, we're going to cut the dovetail first, since it's the most sensitive. We'll cut it, get it right, then we'll carry it over to the bandsaw and take out this big hunk and come back to the mill and dress this up for the final use. So I'm going to get again the camera reset, and we'll take some measurements on one of the tool holders to get the specifications for this dovetail. All right, I got one of the quick change tool post tool holders here, and first thing we're going to do is measure between the high spots, and on this measures 1.355. So I'm going to make a notation of that. Now the critical measurement, the one you want to get right, is the space in the deep part of the dovetail. And the way to measure that is with a couple of pins. Pins do not have to be the same size. They just need to be where they will go up in that groove and stick out past this edge. I'm using a couple out of my pin gauge set. Happens to be the first two in the set, a 251 and 252. But just put those two pins in. Again, it doesn't matter what you use as long as it goes up in that dovetail, and you use the same ones to measure the product that you're developing. All right, I'm going to use an adjustable parallel here. And let me get something to tighten it down. Hold that fairly snug. Tighten it down. And that measures 1.008. That number has no particular value, I mean no particular significance, other than it's the space between the two pins that I chose to use here. So that when we're cutting the dovetail, we use the same two pins to measure with and looking for that same 1.008. We'll get our stock set up on the mill, and we'll come back, I'll get the camera set up over there, and we'll start working on the dovetail. I want the high point of the dovetail to be about 1/2 inch from this end. So what I've done is take that 1.355 that we measured in between, divided it in half, and added to it that ½ inch. So 1.178 will bring us from this edge over here, will bring us to the center. Now what I'm going to do is mill down. I've got me a couple marks scribed that I'll stop just short of and start measuring. But I'm going to make a pass through the middle first, right directly through the middle to get down to our depth. Alright, zeroed out the DRO there. And we said we wanted that depth to be, okay, that was one measurement that we didn't take yet. It's what we wanted that depth to be. Normally on these dovetails, there's a high on each side and a little relief in the middle. We want to measure to this high spot. Just to where we're on the bottom. That measures 0.375, 385, 384.384. So let me make a note of that. And I'll 384 down at this point. All right, I think we're ready to start cutting now. So we've got zero set. We're on the center of where we want our dovetail. All right, I've got a good looking dovetail started in there now. What I'm going to do is knock these chips out of the way. Be sure there's no evil burrs in there. Then I'm going to take the same two pins that I used on the test piece. Place them in there. Get the adjustable parallel. All All right, now we'll step over to the micrometer stand and check this. All right, folks, I like to messed up. I kept cutting, and that's 1.009. We were looking 1.008. 1/1000th is not going to hurt me, but that was cutting it off. Way too close for comfort. What I'm going to do is take the quick change tool post off of the lathe. Since it's very simple to take off, bring it over here and double check it in that. All right, I've got it run out to the side over here now, where I can get to it. And that locks in there just fine. Slides in and out just like it should. So what we'll do now is go over to the workbench and lay out where we're going to make the cut with the bandsaw. Okay, according to our drawing, the side with the dovetail needs a 1 inch left on that side. So I've got the height gauge over here, and let's go up 1 inch. And I'm going to mark that all the way around, because I'm not really sure which side will be out when I wind up with it on the table saw or on the bandsaw or in the mill. All right. Now, this arm that sticks out here is to be a 1/2 inch. That will be this side. Double check to be sure. Be this side right here. All right, you probably can't see the marks over there, but have 1 inch over here and the 1/2 over here. So I'm going to carry this over to the bandsaw, and I'm going to rough that out over there and then get it set up on the mill and bring you back. All right, I'm back from the bandsaw now, and I've got this huge section cut out of here. I actually got a block that's probably may be usable on another little task, but we're going to mount this in the vise now. And a little trick I learned watching one of Tom Lipton's videos a while back. Instead of coming up here and touching off on this top and then coming down 2 inches, in this case 2.5 inches, I'm just going to touch off on the parallel, not under power, of course. All right. Now, zeroed out the z-axis. Now, this section was to be 1/2 inch. So I'll just come back to 0.5 on the DRO and lock down. And now I've got, it should be coming to my line, and we'll leave the 1/2 inch in there. All right. This is a brand new Niagara 5/8 inch end mill, which is, it's a double-ended end mill, so it's long enough to reach this full length here as well. All right, that's about as close as I can get on that. So we'll come out here now, turn our piece around. Now this side is 1 inch. So again, just like before, now let's come back and touch off again, reset 0. Now come back to 1 inch. All right, that's got a good sharp corner in there. Now, while I was laying out a while ago, after I stopped the camera, I actually went ahead and laid out where this 3/8 hole will drill all the way through, and also where the number 8 socket head cap screw will be drilled in this direction. So I'm going to get the drill chuck installed, and I'll bring you right back. All right, I'm ready to drill out for the through hole that the indicator will actually go in. I'm going to have to be a little bit creative on this setup right here, because I don't want that tilting over when as I'm putting pressure on. I'm going to get that seated down in the vise. I'm going to set a couple of parallels across here just for this little jack. This is just nothing more than a piece of aluminum stock that I made a jack out of, and I'm going to run that in there and just keep it off just catch it under the edge where this drilling through shouldn't run into it. It's obviously not a big loss if I do hit it. It's just a 5/16 bolt in there. And I have a pointer in the chuck now, just to use to match to that hole, or to that punch that I laid out. All right, lock the table down. And this is a 23/64 bit, one size under 3/8. And there's plenty of clearance in there, so I shouldn't have an issue running the reamer. I'm going to use a 3/8 chucking reamer. All right, that goes in fine. So now we'll get set up to drill this clamping hole. This is going to be a slit cut through here. Probably the last thing we do. But we want to get set up now to drill this 832 through here. That'll be the tightening bolt. All right, we just drilled this hole through, and now we want to drill for the clamping socket head cap screw that'll be used to clamp these together. I've got a couple of parallels in there. I'm going to get it over the vise. For this back parallel, I'm going to leave over a little bit because I want to drill all the way through. And of course, I don't want to strike the parallel. Drilling this all the way through with the tap drill for an 832. Now I'm going to drill down half the depth with 11/64, which is the clearance drill for 11/64. So I set my Z-axis DRO. I'm not going to use the fine feed down and drill down a 1/2 inch. Now I need to get the tap wrench to finish that. That counter bore needs to go down 160 thousandths. So 0 out. All right, now we need to get this set up, which all I need to do is bring this out, get that parallel out of the way, and get the slit and saw put in, and then we'll cut this slit in here. I have a workpiece slid out now from off the edge of the vise. Got plenty of room in there. And I'm going to take the slit and saw, I've got it in. And the way I like to center, fine center with that is touch down, 0 out the Z-axis DRO. Now come to the bottom. And that reads, let's be sure I don't have a burr under there, which I did. That reads 1.082. Half of that is 541. So no matter how thick your saw blade is, this will find the center. Give it the eye inspection, and that looks good. All right, all we've got left to do now is a little bit of deburring and taking care of some of these sharp corners on there. I'm going to take it over to the belt sander and just ease off some of these sharp corners, nothing spectacular or anything. And then I'll bring you back and we'll be ready to do a recap. Okay, I think we're ready to put our pieces together. Got our socket head cap screw. And I don't think I mentioned it before, but this is one of the large size, standard size dial indicators. I believe they call them a 2 1/4. But we'll put that in there. Now we don't want to tighten this real tight. That kind of negates the advantage of this. We just want it where it's good and snug, where it won't slide out, but yet we can still turn it. All right. So here we have, and again, that's not much different or not than one that would mount off the side here, bump up to your piece of work coming out of the chuck. But the advantage of this one is we simply take it off, turn it over, put it on that side, and flip our indicator. And then we can use it to test a piece of work. Of course, I've got the collet chuck in there now, but if you had a piece that was too thin to set back against your jaws and your 3-jaw or 4-jaw, use that to keep it, to be sure it's lined up on this axis. So I hope you find that little tool useful. Very simple to make, as you've seen. It doesn't use up one of your tool holders. And so far, it's got two uses. This axis, the X and the Z axis, on the lathe. In an upcoming video, I think I'll probably show one more modification to this to give it another use, or actually two more modifications to give this same setup without changing anything other than twisting. Give it two more uses. Again, hope you enjoyed the video, and we'll see you on the next one.